Welcome friends. In this particular lesson, we will learn about increased safety. That is another technique for explosion protection. We have already learned about explosion proof and pressurization, and this is another important technique and also very popular one because cost for making this type of housing is lesser than the flame proof housing, but it serves the same purpose. So it is quite popular. So we will discuss about the working principles and general design guidelines, and also at the end we have a difference between the explosion proof housing and this increased safety, so that there is no confusion in your mind about EXD and EXE. So let's begin with the lesson. So this particular principle is suitable for zone 1 and zone 2, and this is a increased measure taken to prevent the source of ignition. So this is basically cuts off. We know all the fire triangle. So this type of protection method cuts off the source of ignition. So protection is achieved by cutting the source of ignition. So this is achieved by choosing component which do not spark, and heat is dissipated in a controlled way so that the enclosure outside temperature does not go beyond the certain temperature at which explosion or fire can occur. So as you can see in the right picture, this is a typical EXE panel. So these are mainly intended for the products in which arc or spark do not occur in normal service or under the fault condition, and in which the surface temperature is controlled below the incendive values that I have already discussed with you. Increased safety is achieved by enhancing the insulation values and creepage and clearance distances between those required for normal service, thus providing a safety factor against accidental breakdown. Okay, what is this creepage and clearance distance? That we'll discuss after some time. So what is the increased safety key design features? Key design feature, first of all, enclosure. Enclosure must be constructed so to withstand mechanical impact and provide a specified degree of ingress protection. In this case, it has to be minimum IP54 rating. Second, terminals for external connection. The terminal that are being used for connecting the electrical wire should be generally dimensioned for intended connection and ensure that conductors are securely fastened. So if the conductor is not securely fastened in the terminal block, there is a chance of sparking due to the loose connection at the terminal. Also, the terminal needs to be the big enough so that the distance between the two conductor gets is sufficient, and sufficient air gap is also present, so that in case of high voltage going through the two conductors, the there is no breakdown of the insulation and no sparking occurs. So as you can see in the picture that what is the significance of uh, proper type of termination. As you can see, this is the correct stripping. This wire, the bare end goes directly inside the termination or TB, and no part of it is outside. Okay, but in this case you see this bare portion I am talking about is too short, so the contact is not making properly. So in that case the heat dissipation will not be proper. In that case it is too long. As you can see, the bare portion is coming out of the terminal block. So in case of the increased safety, we should be very careful. We should be very careful about our wiring inside the terminal box. Third is internal connection. This is, first we talked about the external connection. Now the internal connection must be subject to undue mechanical stress and shall be made using the specified method. Obviously, the internal connection of has to be without any mechanical stress, so that there cannot be any loose connection or something like that, which may result in spark